The power of nuclear weapons versus TNT. 1. Introduction. Hi friends. Today, we're going to explore an absolutely fascinating and mind-blowing topic: the power of nuclear weapons compared to traditional TNT, trinitrotoluene. You've probably heard about nuclear bombs being unimaginably destructive, but what does that really mean? How do they compare to regular explosives like TNT? What makes nuclear energy so much more powerful? And most importantly, how can we visualize such immense energy? Well, let's dive in and unpack this step by step. 2. What is TNT and how does it work? Let's start with TNT because it's something we can wrap our heads around more easily. TNT, or trinitrotoluene, is a high explosive commonly used in mining, construction, and military applications. It's powerful but relatively stable, making it safe to transport and store. When TNT explodes, it undergoes a chemical reaction, breaking its molecular bonds and releasing energy in the form of heat, pressure, and shock waves. 1 kilogram of TNT produces about 4.18 million joules of energy. To put this into perspective, that's enough to boil around 3 liters of water instantly or power a 100-watt light bulb for about 12 hours. 3. The unmatched power of nuclear weapons. Now, let's talk about nuclear weapons. Unlike TNT, which relies on chemical energy, nuclear weapons release nuclear energy, the energy stored in the nucleus of atoms. This energy is millions of times greater than chemical energy. There are 2 main types of nuclear reactions used in weapons. Fission, splitting the nucleus of heavy atoms like uranium-235 or plutonium-239. Fusion, combining the nuclei of light atoms like hydrogen to form helium. In both cases, a tiny amount of mass is converted into energy, as described by Einstein's famous equation, E equals mc squared, where E is energy, m is mass, and c is the speed of light. 4. Comparing the power, TNT versus nuclear weapons. Let's make this comparison more tangible with some examples. Energy released by 1 kilogram of uranium-235. If you fission just 1 kilogram of uranium-235 in a nuclear bomb, it releases about 17.6 trillion joules of energy. That's equivalent to the explosion of 4,184,000 kilograms of TNT, more than 4,184 tons of TNT. To visualize this, imagine 4,184 large trucks, each carrying a ton of TNT, lined up in a convoy stretching several kilometers. All that energy can be released from just a single kilogram of uranium. The Hiroshima bomb. The atomic bomb dropped on Hiroshima in 1945 had a yield of about 15 kilotons of TNT, meaning it released the energy equivalent to 15,000 tons of TNT. In comparison, a typical stick of dynamite contains about 0.2 kilograms of TNT, so the Hiroshima bomb was equivalent to 75 million sticks of dynamite. Modern thermonuclear bombs. Today's thermonuclear bombs, hydrogen bombs, can yield up to 50 megatons of TNT or more. That's 50 million tons of TNT, equivalent to the combined energy of several thousand Hiroshima bombs. 5. How do they work? How does TNT explode? When TNT detonates, a chemical reaction breaks its molecules into smaller gases like nitrogen, carbon dioxide, and water vapor. These gases expand rapidly, creating a shock wave. The reaction happens so fast, in microseconds, that the energy release feels instantaneous. How do nuclear weapons work? Nuclear weapons, on the other hand, rely on chain reactions. In a fission bomb, a neutron strikes a uranium-235 or plutonium-239 nucleus, splitting it into smaller nuclei and releasing more neutrons and energy. These neutrons then split more nuclei, creating a rapid, self-sustaining chain reaction. In a fusion bomb, the intense heat and pressure from a fission reaction force hydrogen nuclei to combine into helium, releasing even more energy. Fusion bombs are much more powerful than pure fission. 6. Real-life comparisons and visualizations. Let's make these numbers more relatable. 1 kilogram of TNT. Imagine a single stick of dynamite exploding. It's loud, destructive, and can cause significant damage to nearby structures. 1 kilogram of uranium-235. Now imagine all the TNT you'd need to match that energy. You'd fill over 4,000 dump trucks with TNT. That's a convoy stretching over 40 kilometers, and all of it represents the energy stored in just 1 kilogram of uranium. 7. Destructive potential. Scenarios. Nuclear explosion in a city. If a 1 megaton nuclear bomb, equivalent to 1 million tons of TNT, were detonated over a city, it could cause catastrophic destruction over a radius of several kilometers. Buildings would be flattened, fires would engulf vast areas, and the shockwave could travel tens of kilometers, shattering windows and injuring people far from the blast. TNT explosion in a city. A truck carrying several tons of TNT could cause massive damage, but it would be limited to a much smaller area. For example, the 2020 Beirut explosion, caused by about 2,750 tons of ammonium nitrate, similar to TNT, devastated parts of the city but didn't come close to the destructive scale of even a small nuclear weapon. 8. Why the difference? The key difference lies in the energy density of nuclear reactions versus chemical reactions. Nuclear reactions release millions of times more energy per unit of mass because they involve changes at the atomic nucleus level, where much stronger forces are at work. 9. The moral and ethical implications. The immense power of nuclear weapons raises profound moral questions. While TNT has primarily been used for constructive purposes like mining and construction, nuclear weapons are overwhelmingly associated with destruction and war. The global community continues to grapple with how to manage and reduce the threat of nuclear weapons. 10. Conclusion. A sobering comparison. In conclusion, while TNT is an impressive and versatile explosive, it pales in comparison to the unimaginable power of nuclear weapons. The energy released from just a few kilograms of nuclear material can rival thousands of tons of TNT. This stark difference highlights the importance of understanding and respecting the power of nuclear energy.